Hi, Christina. How are you?
Hello, good morning.
Good
Good.
morning.
Ready to start.
Good
Uh,
morning,
Yes.
guys.
Good morning.
Hello.
Ready to start, but we'll wait a couple of more minutes until everyone is getting into this session.
Sure.
Okay, thank you.
Bună dimineața! Spuneam mai devreme că mai așteptăm câteva minute până intră toată lumea în sesiune.
Cred că trebuie să vină tabla. Deschide ușa. Da. Okay.
Morning.
Good morning. Hello. Prezentarea firmei. Altul, prezentarea firmei. Da, știu, da. Ok. Prezentarea individuală sau cu tot grupul? Ok. Păi cred că suntem toți. Da.
Not yet. We are supposed to start at 10. We'll wait one more minute because not everyone has joined yet.
Tot mai aproape. Nu mai. Da, nu e ok. Asta.
Hi, guys. I will try to make a call for the ones who didn't come up yet.
Okay, perfect. We'll wait 1 or 2 more minutes.
Okay. Grazie, grazie.
Hi, so I think we're good to start. I spoke with Shai from Storage Door. Fortunately, he has some issues. It was a car accident in his way to office. So he might not be joining us, but he will do his best to join as fast as he can. I just suggest that we will start without him, and maybe he will join us.
Okay, perfect, Itai. Thank you for letting us know. Okay, so hello everyone, good morning. Thank you for joining us today. Nice to meet you. I'm Cristina Moraru from the Economic and Trade Mission. I am in charge of the energy and water sectors, as some of you might already know, and today I will be moderating this session. Before we start, I want to present you a little bit the rules of how things will be going on today. So we will have opening remarks, presentation provided by Mr. Lasker, and then we will move to the Israeli companies' presentations, which will have 15 minutes each. And then we will move to the B2B session, for which you will be designated or you can join by yourself the special breakout room. In case you need any assistance with that, you can leave a message in the chat box or just unmute yourself and let me know, and I will help you with that. Okay. I hope today's session will be fruitful and you will find the entire presentations interesting to launch the dialogue between Romania and Israel. So I am inviting now Mrs. Abigail Stambler-Paz, the head of the Economic and Trade Mission, to address a few words. Abigail?
Hello, thank you. Thank you, Cristina. Good morning, everyone. Bună dimineața. So I'm the head of the Economic Mission of Israel to Romania. We represent the Israeli Ministry of Economy and Industry, and we are part of the Israeli Embassy in Bucharest. So I would like to thank Itai from the Israeli Export Institute for helping us selecting very nice cutting-edge Israeli technologies for this webinar, and I will not take any more time from the most interesting part, but Itai, please say a few words before we move to the professional presentation. Thank you.
Okay, thank you, Abigail. So, hello everyone. Thank you so much for joining us today. As Abigail said, my name is Itai, and I'm from the Climate Tech and Smart Infrastructure sector at the Israeli Export Institute. Now, for those who are not familiar with us, the IEI, the Israeli Export Institute, is a non-profit and a semi-governmental organization. Our main goal is to assist Israeli companies to scale up globally. We operate in 15 different sectors, such as energy tech, medical devices, digital health, cybersecurity, HLS, and much more. But we're not doing this alone. We do this with our natural partners, the Foreign Trade Administration in the Israeli Ministry of Economy. And for that, I would like to thank again to Abigail and to Christina for their collaboration and for making this event possible. I would also like to thank Amos Lasker, which you all gonna hear really soon, and for the amazing companies that will present their innovative solutions today. I wish you all the best. Thank you and good luck.
Thank you, Itai. Thank you so much for all the help you provided in organizing this event. Now I'm inviting Mr. Amos Lasker to present a couple of more valuable information about Israeli energy sector.
Hi, thank you. Good morning. Let me just share the screen. 1 second. Okay. Yeah, it's. Do you see my screen now?
Yes, yes.
Okay,
Yes.
great. Okay, so again, thank you very much. Happy to participate in this webinar, and thank you for inviting me. My name is Amos Lasker, and I am here as founder and CEO of EnergyCom. EnergyCom is a non-profit semi-governmental organization. We have, it says here 5,300, actually we have close to 6,000 members from all the ecosystem, renewable, fossil fuel, private and traded companies, matured and early stage, regulators, VCs, CVCs, investors, and others. So first, let us, I'll give you a general overview of what the Israeli energy market, emphasizing, of course, about innovation. But first, let's look at the main drivers of the Israeli energy market. So first, we enjoy a fast growth rate. Last decade, 4.5% per annum. Next 10 years, the focus is about 2.5%. Very impressive comparing to any other developed countries. We are an electrical island. For obvious reasons, we don't have a mutual grid with our neighbors. It means that we have to generate and supply all the energy to all the end users. We are shifting from coal to natural gas and renewables. Actually, the government set a target of closing all coal power stations by next year and reaching 30% renewable by 2030. Back in 2017, the market went through a deregulation process, opening generation and supply to competition. Last but not least, we are following the developed countries and we are moving from vertical to distributed network. And this, of course, has a significant impact on the participation of the high-tech community in the energy field. Well, Israel is known as the high-tech nation. So what are the main drivers to Israeli innovation? So first is the Jewish mother. 30, 40 years ago, she pushed her children to be lawyers, doctors, accountants. Now being exposed to the exit opportunities, she directs them to be part of the high-tech industry. Second is the Israeli DNA. We are not so good in organizing, planning, working in defined methodology, but we are excellent at solving problems, in improvising, in thinking outside of the box. All these qualities are precondition to being innovative. Another interesting phenomenon is the conversion of military technology to civilian needs. Most of the military industries have opened subsidiaries to handle the commercial markets. Finally, is the paradigm changes from vertical to distributed network. It opens vast possibilities for utilizing existing management and control system for energy purposes. So let's take some examples. The technologies that you see here, forecasting, big data analytics, blockchain, machine learning, AI, cyber, and others, were traditionally used for telecommunication purposes, smart production lines, software application, and others. Now, looking at distributed energy, they are being utilized for renewables, energy storage, energy efficiency, alternative fuels, EV charging, and others. Another way of, let me just see that it's going. Another way of looking at the market is by defining what sustainability innovation consists of. It's a mix of energy, water, transportation, and advanced industry production. And within the energy sector, we see the key areas are renewable, storage, distribution, and energy efficiency. I would like to point out the importance. Sorry, I jumped one. Well, it seems that I'm missing one of the slides, but in any case, yeah. So I would like to focus for the next 2 minutes about the role of the Israeli government. It's very crucial for the success of the high-tech community. The government has multiple organizations supporting the industry. Let's look at one example, the chief scientist of the energy ministry. They offer actually 3 vehicles: direct support to early stage startups, participation in pilots project, and financial support to R&D in the universities. This last element is very important, as a lot of innovative ideas are being originated in the academy. Looking at the categories, we understand the priorities. All types of categories are related to distributed energy, except for nuclear energy, which in any case is not relevant for us in the short and medium term. We saw the government priorities. Now let's examine the private sector preferences. As you see here, first come energy generation, and I mean here in our country in Israel. It's very natural, as the world is constantly looking for replacement of a fossil fuel. Storage, which in a way is an alternative to production, comes second. Energy consumption and energy efficiency come third, as the kilowatt you save is the most expensive one. Then the transmission also plays a significant role, and the ways to energy and emission reduction require probably more attention. Sorry. Energycom, the innovation community of Israel, publish each year a mapping report of all energy companies classified according to sectors. It's the best guide to key companies, startups, investors, and academic researchers. What we see here is the 2024 report, which lists 236 R&D companies. The dominants, as you can see, are in the area of renewable, distributed energy, and energy infrastructure. There are about 60 service companies and about 50 VC and CVCs and incubator dedicated to energy environment. Pay attention to the academic researchers. About 60 PhD, postdoc, and professor from different faculties focusing on energy and climate change. The 2025 edition is ready to go and will be in our website on April 1st. In terms of R&D, you can see here the division by sectors. I would like to emphasize the dual-use companies, the agrovoltaic initiative. As we here in Israel, we suffer from land scarcity, so we have developed a very sophisticated methods to combine PV panels over field crops. The innovation here is to optimize production without harming the agriculture. So this was a very, very, very brief presentation of the situation that we have now here in Israel. As I mentioned, we are a company for the benefit of the public, so feel free to touch base, and we'll be happy to assist you in any matter relating to the local market. Thank you.
Thank you so much for the presentation, Amos. If anyone has questions that you want to address to Amos, you can add them in the chat box, and we will address them at the end of the presentation session. Thank you again. Now we are ready to start the company's presentations, and I'm inviting Tomer Stern from Lava to take the floor. You have 15 minutes. I'm starting the timer.
Good morning, everyone. 15 minutes, it's too much for me. It's okay. Good morning for everyone. Nice meeting you all. Tomer, VP Product of Lava, and I will just describe in a bit our solution that we are developing as a technology that supports heavy industry decarbonization and optimization in the form of heat engine and heat pumps. So I will just share a presentation. If someone can approve that it's seen in full screen, just a minute, in full screen, we're good?
Yes.
Okay. So what we are doing and what problem we are challenging? The problem in heat engines, that's all of the heat engines that we know, all of the technologies, and heat engines are basically the engines that we know from our car, from jet engines of airliners, and also as a steam turbines and organic Rankine cycles. All of them are working in an inefficient Carnot cycle. This is called an isentropic cycle. It's inefficient, but currently it's the only way to make energy, to make use of an energy or heat and produce electricity. So basically, we're achieving 50% of the optimal efficiency that we can get. We call it the Carnot efficiency. What we've done at Lava, we actually developed a new thermodynamic cycle and realized it into a heat engine. And we are taking the red line and moving it to the blue line. The blue line is isothermal expansion. By utilizing a heat engine that performs isothermal expansion, we are gaining, instead of 50% of the optimal efficiency, between 80 to 90% of the optimal efficiency. And it's directly translated to operational efficiency and to greenhouse gases reduction. So how do we do it? Or how do we utilize it into a product? We use our isothermal expansion and compression, and we invented and developed two products. One of them is the heat engine that transform heat, waste heat that emitted to the atmosphere, into electricity. And the second product is heat pump that basically take electricity from the grid and transfer it to heating or cooling, depending on the application product. And again, with a coefficient of performance, it is groundbreaking. So a bit about physics. It will be quick, and I will happy to answer in the Q&A. How do we do? And how do we develop actually the isothermal expansion? We developed actually a nozzle. This is a very simple nozzle where we are taking the heat from our customers in the forms of waste heat. The heat can be in temperatures of between 100 degrees Celsius to 500 degrees Celsius. This is the industry main applications in this range. We take a heat transfer fluid and actually harvest the heat from the customer with a heat exchanger, and then bring it to our turbine, and it ends in working in this specific nozzle. This is obviously a simplified version of our nozzle turbine, and the heat is coming in the temperature, and then in the end, in the nozzle, we're injecting a liquid that evaporates very quickly. We are mixing two liquids and then separating them. While the liquid evaporates instantly, it's creating bubbles. The bubbles are injected in almost ambient temperature, but because of the heat capacity of liquid versus gas, this is 1,000 times more. The bubbles instantly getting the temperature from the liquid and they're starting to expand. What happens when bubbles start to expand, as ideal gas, is that they are proportionally cooling down by the volume of expansion. Because in our patent, they are surrounded by hot liquid, they absorb instantly the heat from the surrounding, and then while they're expanding naturally, this is physics and we cannot hit it, they're expanding naturally, they're keeping the temperature because they are absorbing the temperature from the surrounding. So actually, they are performing expansion. And in the end of the nozzle, we have a mix of bubbles that has been expanded and liquid that's creating a jet. Just to understand, the bubble started with as a 3% of a volumetric fraction, and they're emitted at 70%. It's creating a two-phase jet, and it's almost isothermal expansion, where we're proved in proof of concept in operating turbine that we can reach 95 isothermal expansion, 95%, or 95% away from the red line that you see into the blue line. So a bit more realization of this technology, and we will continue. Now, again, if someone can prove that you are seeing the video.
Not
Yes,
yet.
the video.
Not yet.
Not yet.
Now it appears.
Okay. So we took a turbine, and as you can see, the orange liquid is injected from the center, and then it meets in the end in the nozzles, our gases or bubbles, and then just emitted as a jet in 90% isothermal, meaning we have two liquids that are mixed together and performing a 95% isothermal expansion. Then the thrust created by these nozzles is rotating a generator that connected directly to a shaft. We have horizontal product and vertical product that you can see here. And we'll continue with the presentation. If you have any questions about this technology, I'll be happy to answer it in the Q&A. Now, this was the heat engine, 70, 80 Carnot efficiency. In the second phase will be 90. This is a translated. You can see the presentation?
Yes.
Yeah, okay.
Yes.
This is translated directly to up to 1 to 3 years of a simple payback time. It depends on the market because we are very cheap, targeting $1,000 per installed kilowatt. And we are 50% more efficient, roughly from the high-end technologies. We are talking about 1 to 3 years of simple payback time, 3 years in a very competitive market like the US, low fossil fuel prices and no incentives. And in Europe, in Germany, we can reach to between 1 to 2 years when we have incentives of a GHG reduction and high fuel prices. This is our experimental field. We are experimenting proof of concept in 2024, third prototype 50 kilowatt machine that is working in a field test environment. This is done in Ormat. They are our
Tomer, you lost connection. Can you hear us? Just a second. We encounter some technical issues. Tomer, are you still with us? Tomer, now you're back.
You lost me in the isothermal compressor. I just verify.
Yes.
Okay.
If you can take it from there and reopen the presentation, the screen share.
No problem. We'll still need the time. It's okay.
Exactly, you still have time.
Okay. Now can you see the presentation? Okay. Thank you for the patience. So we actually performed an isothermal compression by sucking the bubbles in form of gases, and then on a closed cycle of liquid, we are compressing them. The gases are emitting energy in form of heat while they are compressed as any other compressor. But when we're doing it without rotating parts, without moving machinery like standard compressors, it's more optimized in terms of operational expenses, reliability, and also we can harvest again the heat because it's not released to the atmosphere, it's released to a liquid, and we are returning it to the cycle. Let's look at the use cases of our heat pump. A very large market of data center expected to grow until 2030 in 150 gigawatts installed worldwide. There's a lot of prediction. It can be 50 gigawatts more, 50 gigawatts less, but it's all guessing, but it's a huge market. the leading edge of the market of cooling chilling water of data center is a coefficient of performance of 4.3, and with our isothermal compression, we can reach COP of 5.8, which is 35% higher, meaning 35 less energy consumed with the high end. This is the 4.3 is the most advanced centrifugal heater that exists commercially cooling data centers. 35 from high end, 50% better than let's say average market cooling products. We are doing the same for district heating with our heat pump, and this is to perform heating from 80 to 90 degrees. How do we utilize it in our heat engine? There are a lot of open cycles in data centers of small turbines. The data centers have to construct in order to supply independent energy off grid. These turbines, mainly delivered by a big manufacturer of Caterpillar subsidiary called Solar Turbines, is working in relevant efficiency. It's 25 to 30% efficiency, open cycle efficiency. When we're connecting our heat engine into the flue gases, we can harvest more energy, and you can see the numbers below. A 1.2 megawatt gas turbine can be boosted up in our combined cycle using our heat engine into almost 2 megawatts by increasing in 63% the capacity of energy, and it's 63% of zero emission electricity. We are targeting a price of $1,000 per kilowatt in the end. We are now reaching $1,500 per kilowatt in commercial products, and we're improving by 50% the gas to power cycle with the heat engine. It means a lot for this industry. We have a lot of partners that were developing big pilots in 2026 with ThyssenKrupp in Germany, first pilot. We have two companies of oil and gas in Canada, in Berkeley, and also a big company in the US that were developing our heat engine to harvest heat out of reciprocating engines and turbines. And we have partners in developing district heating with our heat pump that they are ready. It's a Spanish company. All is patented. The main patent is already passed in the US. We have 9 more patent families in advanced processes. Very big experience. We have 32 employees. We started with 5 employees 3 years ago when I joined the country. Now we're 32. Most of them are engineers. The management has a broad experience with technology and the academy. Professor Carmel Rothschild, that is patents registered on him, is an associate professor in the highest technical institute in Israel. And the rest of us are very experienced from the power industry. I will not extend it, but we are developing a long duration storage of a Carnot battery. It's a mix between our heat engine and heat pump. We are taking from the grid electricity or from renewables, boost it up into a thermal energy to 200 degrees Celsius, and then using our heat engine is very efficient at 200 degrees Celsius. We're creating a round trip efficiency of 60%, and it can financially reach 110% when we are using low prices or negative prices on available grid energy when it's a low demand. This is the storage that we are developing. It's a thermal storage with a solution of salt 200 degrees. We are charging it with our heat pump, discharging it to the grid with our heat engine. This is the concept. I wish to thank you all, and I'm open for questions.
Thank you, Tomer. It was a nice presentation, really comprehensive. Just to let the new participants that joined the session, if you have any questions, you can add them in the chat box, or you can join the designated breakout room of the company to address the questions directly to the representatives afterwards. Thank you. Now, we are moving on to the next company, which is Finergy, represented by Dor Ganor.
Hi, everyone. Yes.
The floor is yours.
Thank you so much. Tomer, it was very interesting. Thank you so much for your presentation. And thank you everybody for joining this session today. And Itai, thank you for approaching. Every time you approach us, we're more than happy to participate in those type of sessions. And thank you again. Okay, so I'll share my screen, please. And okay, okay. All right, can you see the full screen?
Yes.
Perfect, thank you. All right, so again, my name is Dor Ganor. Wait a minute, I see that my video is moving slow. So I will just, okay, I'll keep it that way, sorry. So my name is Dor Ganor. I'm the Director of Biz Development at Finergy. Finergy is a clean energy solutions. It's a clean tech company, publicly listed at the Tel Aviv Stock Exchange. The company was founded in 2009, and we have developed a technology called metal air technology, basically turning aluminum into a way to store, transport, and generate clean and safe energy. We are the first company in the world to have a commercial product that is based on that technology. And we have already hundreds of backup energy systems, clean backup energy systems, deployed and providing backup energy in Israel, Europe, and India. So I'll start with the technology. I'll keep it high level. If you would like me to dive deeper, we can discuss later. But if you can see what I'm holding here in my hand, basically it's aluminum plate. Mankind uses aluminum, for more than 100 years to build, airplanes for construction. This is the most abundant metal on Earth. It's cheap, it's light, it's inert metal, so basically it's non-flammable, non-explosive, and it's also recyclable, and also the energy density is compared to other fuels is comparably high. So I'll just make it a bit simpler. So let's say we have a diesel generator. The fuel is obviously diesel. We have a hydrogen fuel cell. The fuel is hydrogen. Our aluminum air generator, our fuel is basically aluminum plates. This is our fuel. So not only these benefits, but also it's very important to mention that if I will leave the aluminum plate here on the table, and we'll come back in 20 years' time, the energy that is stored in this plate will remain the same. So basically, there's no energy degradation that you can find in other technologies. So a little bit about the ecosystem. So aluminum production is there, the ecosystem is there. There's no need to invest a lot of billions of dollars or euros into establishing an infrastructure such as hydrogen, for example, or other fuels. So the ecosystem is there, and the aluminum production processes mainly happen in places where the energy is cheap and available. These places, such as Norway or Quebec, the local market demand for energy is way lower than the supply of the hydroelectric power plants, the energy that those plants supply. So basically, aluminum smelters are located there next to hydroelectric power plants, and they use the energy from the waterfalls basically to inject into the metal, because this is part of the process of manufacturing aluminum for more than 100 years. And so basically, any aluminum that you'll find around yourself, such as the window frames, for example, the aluminum has energy stored inside it. And most probably, the energy that is stored inside any aluminum around yourselves is clean energy from hydroelectric power plants. So basically, as we all know, the aluminum is being transported all over the world. This already exists, and we have basically developed a way to, phase number 3 here in front of us. Basically, we are doing the reverse process. We are oxidizing the aluminum plate in order to generate electricity. And once it is generated, there's no material loss. It is a zero emission process, basically through an electrochemical reaction. we produce electricity, and then we can send it back to the aluminum smelters. So basically, we have also a circular economy type of technology and application. We operate in two main segments. The first one is the telecom market. I already mentioned we have a commercial product that is tailor-made to the telecom market, and we have hundreds of systems already deployed and provide backup energy to telecom sites. And the other segment is the data center market. Tomer mentioned a little bit about the data center market. I will further elaborate in a minute or two. But basically, we work on developing a larger product to provide energy backup to data centers or larger consumption facilities, or commercial industrial facilities, etc. I'll start with the telecom market. We work with the largest tower companies in Europe, such as Vantage Towers, Cellnex Towers. We're an official supplier of Ericsson. We work with the largest Indian tower company, Israeli mobile network operators, the Israeli utility company. Basically, our backup energy aluminum air solutions provide energy backup to those customers' telecom sites. Some more benefits about our solution. Our solution is CE certified. As I mentioned, zero emissions, no noise. Our solution has 70 kilowatt hour. It's a 60 by 60 centimeter cabinet, like a regular, like a normal telecom rack cabinet. And it provides, so let's say, like an average telecom site would be 4 kilowatt of power. It means that we have 18 hours of backup energy within this cabinet. So basically, our solution replaces the generators, lead-acid batteries, lithium-ion batteries, hydrogen fuel cells, etc. Now, our solution is not only hardware. I mean, we provide our customers also with a software. So basically, our customers they have the option to monitor their energy assets across their network on a high level. And also, if they deep dive into each and every one of their sites, they can monitor, for example, how many power outages there were in this specific site, what was their length, and also what is the remaining energy, what is the remaining capacity in each and every site at any given moment. It's important for me to mention, to emphasize that our energy backup solution is autonomous. So it will provide backup energy, whether it is connected to the cloud and provide us the monitoring capabilities, and even if it's not connected to the cloud. More so, I would like to mention another important benefit about the solution. So, as I mentioned, aluminum is inert; it's non-flammable, non-explosive. So basically, our technology, our solution is very safe. You don't need to implement safety measures in your site, and also storing energy is fairly easy, because at the end of the day, you might have a warehouse or a local service provider that has those aluminum plates, and also this liquid electrolyte, which is non-corrosive and doesn't require any special measurements, and basically keeping this fuel there indefinitely, let's say. Now I will touch the data center market. The data center market, as we all know, is booming. I mean, those giant companies, the hyperscalers such as Google, Microsoft, Amazon, Meta, Apple, they are leading this market with the growing demand for AI and for storage. This market is booming, and also these hyperscalers are the first ones to commit to net zero carbon on their site. And currently, as of now, they haven't found yet a solution that will be a great alternative to dismantle and remove those giant diesel generators that provide backup energy to their data center sites. Also, on the right-hand side, we can see the growth of the market. On the left-hand side, we see that the market is highly centralized. So 70% of the market is basically led and owned by those five hyperscalers, which business-wise, it makes it easier for us and other players to to gather market ownership, let's say, or gain market share. Now, as I mentioned before, telecom market or small consumptions, we have our commercial solution. And for the data center or other larger consumers, for such as commercial industrial facilities, etc., we develop a larger, like a containerized solution. 40-foot container, aluminum air. It would be 800 kilowatt and with 48 hours of backup. As you can see here, there's no technological challenge. We're talking about engineering acceleration process. So the air electrode, this is our secret sauce. We manufacture it here in Israel. We have an automated manufacturing plant. And also the aluminum air stack of cells. This is already part of the telecom product. So basically, in the containerized solution, we're going to use the same building block, these aluminum air stack of cells, and basically multiply them to a larger number to get more power and more capacity. A little bit more about the challenges that those hyperscalers and data center market are facing. Obviously, these are gensets struggle to meet hyperscalers net zero carbon goals. Not only that, but also, asking for going to apply for a permission, like a permit to build a new data center, you have to provide the municipality or regulators a lot of documents, obviously, and having giant diesel generators on premises makes a lot of difficulties to those data centers, real estate developers. High maintenance requirements that diesel generators require, and there are currently limited clean tech alternatives to replace those diesel generators. Here we can see, the main most popular solutions. As we know, diesel generators and biodiesel generators, their cost is okay, is cheap compared to other solutions. The power footprint is great, 15 to 25 square meter per megawatt, but it is not safe, and it emits NOx emissions and CO2. Hydrogen fuel cells, it's double the price, much larger footprint, and it's not safe. Also, lithium-ion batteries, as we all know, it's highly flammable and explosive, and it require a larger footprint and in terms of cost. Although the cost has declined dramatically in the last couple of years, having such a backup energy for 48 hours for a lot of power would be for megawatt is fairly more expensive. So our aluminum air based characteristics based on large scale production, the cost would be even cheaper than diesel. So when we sit with those hyperscalers in the same room, clean and everything is nice. I'm sorry to say it out loud here in this room, but at the end of the day, you have to be also competitive in terms of cost, and the green that talks is the money, unfortunately. But this is what we know and what we feel. So our aluminum air solution for this application at a large scale production would be even cheaper than diesel generators. It would be around, or let's say double the footprint of diesel generators. It is totally safe. It is totally clean. Now, as I mentioned, economics always win. Data centers at the end of the day are real estate projects. So the more footprint you need, the more square meter you need, the more money you'll have to pay to your landlord. Also, in terms of permission to build, to develop new data centers, our solution, since it is clean, no permits for health or hazardous emitters will be required. And also in terms of safety, it is not flammable and not explosive. Really makes the logistical and operational effort a simple effort, a much simpler effort than the other solutions. I try to keep it as concise and quick as possible. Thank you so much. And I'll be more than happy to answer any questions later on. Thank you.
Perfect, Dor. It was roughly exactly 15 minutes.
Beautiful.
Thank you so much.
Thank you.
Now we are moving to the next company, which is SolarGeek. Moshe, are you still with us? Yes.
Yep, I'm here. Happy to jump on. And is my screen showing?
Still loading. Yes, now we
Okay.
can see it.
And I'm actually in Lisbon at a conference, so I stepped aside and hopefully the Wi-Fi here is okay. Let me know if somehow I become choppy. So thank you for the opportunity. We're excited to speak today a little bit about how SolarGeek can help unlock some of the solar energy in Romania. We know that there's tremendous growth going around in the country and then a lot of ambitions in terms of installing gigawatts. So we're excited to see how we can help with that transition. So SolarGeek is a solar tracking solutions company. We are a solar tracker, so that is the hardware that moves the panels to better face the sun. It allows us to generate more energy for especially small scale and utility scale projects. We have several hundred projects globally, about 20 countries, and a strong leadership team coming with generations of experience in the solar industry. And you can see on the bottom a few of the leading European IPPs that we're already working with. We're unique in that we are not just doing the hardware piece, but as Amos described before, innovation, right? We're combining the software and the hardware to create a very tailored solution that can be specifically adjusted to the customer needs. And specifically for Romania, we know that the market is expanding rapidly, about 2 gigawatts being installed every year, with a goal of reaching closer to 8 by 2030. And we believe that some of the biggest constraints or challenges we're facing right now are actually around land, right? And one of the missions that SolarGeek has is being that innovative solution that can unlock more land and allow for this growth of solar energy that we know is expanding in Central and Eastern Europe. Specifically, one of the reasons solar energy and a few of the previous presentations talked about the importance of techno-financial, right? It's about the right color of green. So we see the same thing in solar in that everybody's excited about the drop in panel prices and CapEx, and we assume that everything is going down. But the one thing that we're not really addressing in terms of inflation is land, right? That's actually the one thing that is going up, and it's a much scarcer resource. And when you start accounting for that, you realize the curve is not flattening. In fact, the curve might actually be rising, right? If we start addressing the fact that land costs are going up, data center expansion, everything that's going on, real estate, booming economies, that actually becomes greater and greater. And one of the challenges we're seeing is in actually how do we unlock that? How do we allow solutions that can actually better take advantage of the land that's being used? Now, over the past two years, we've seen really, really interesting shifts in energy prices across Europe. We think of the daily production curve of a solar plant, right? Less in the morning, a lot in the middle of the day, and then declining in the afternoon. And then when we look at hourly prices, right, we know that especially during midday, we even have negative prices, right, where you're actually paying in order to generate energy. And we see that it has a different shape than the solar plant, right? And it's actually not a bug, it's a feature. It's not a coincidence that energy prices start rising just as the production is coming down. And the more solar energy we put into the ground, the more this is actually going to happen. That's one of the main reasons we're seeing a shift to what we call trackers, right? Trackers, by following the sun, it's not just that they're creating more energy during the middle of the day, they're creating this energy in the shoulders, right? Which is exactly when we need it. And if you think about the multiplication effect here, right? Generating more energy exactly when that energy is expensive, right? We actually see that the profitability gap between a standard, what we call fixed project versus a project with trackers, the large majority of that value is actually going to be created in the shoulders. In the morning and the afternoon hours, that's when the value is. Clearly, batteries, BESS are going to be part of this solution. Everybody knows that. Until the prices come down to make that more accessible, we're going to still see this big shift in pricing. So what are we doing to help solve for some of these challenges? One, we're looking to create projects in more and more places that previously were not possible. We're looking to use trackers that are more efficient, both in terms of generating more energy at a lower cost. And as this entire grid gets digitized, we're focused on providing controls for our customers to be able to see and monitor and control these projects in real time. Land utilization. So when we think of a solar project, this is what we probably imagine: nice, flat, simple, square, symmetrical. And life would be wonderful if this is what we were encountering. Now, most of the trackers and the manufacturers in this industry are still building their trackers for this environment. Big, bulky, one motor moving hundreds of panels. They're not wrong. That's what the old world looked like. So that's why they created these solutions. But we don't always get to choose where we build. Sometimes this is what life gives us, and we have to make lemonade with these lemons. We have to figure out, how do we develop projects on challenging terrains, weird shapes, bad locations? We still have to be able to use these types of projects. And for that, we believe there's a new approach. The approach for this is building a different tool set. Instead of taking simple blocks that can build very simple projects, we're making smaller building blocks that you can build much more sophisticated and complex and powerful and profitable projects. So we're giving our customers much better tools to build these types of fancy projects. To give you an example of what this does to a design of a project, what you see on the left is a project that we were designing, or the customer was designing. We looked at it and it was 33 megawatts. Now, like our kids who sometimes eat the middle of the sandwich, the designer did the same thing. They used all the middle land, but they left all the crust around it and they didn't put anything on it. Why? Because they didn't have the versatile building blocks to do that. When we looked at this, we realized, wait, there's an additional 4 megawatts that can be put in here. And we were able to increase the amount of installed capacity by 10%. Now, 10% might sound like not a significant number. In many cases, that's the difference between this being a viable project versus falling to the wayside and not actually getting developed. And here are a few examples where you can see, because we're using blocks that are much shorter than the other trackers, we can get as close to these edges as possible. We can use every single square meter of these plants to generate energy. If you're doing behind the meter or supplying factories, especially in Central and Eastern Europe, we've seen this, that is oftentimes a very big difference in terms of the IRR and the profitability. So what are we doing that no one else is doing? Instead of using the big, massive motors that I showed you before, we've created our own in-house solution. We take readily available gears and simple motors. We combine them with our own printed computer chips and 6-watt small motors, and we're using this to be able to power our trackers. It's very simple to install, which also makes it easier for the installation and actually reduces the cost. To give you an example of what this does in the field and why that versatility is helpful for customers, this was a project actually in India, 6.5 megawatts for a factory. We shipped all the products. The customer was ready to build. This is what the layout looked like. And then what happens when you have brothers doing business? They get into a fight. One brother said, you know what? I'm taking out. This is my land. You can't build here anymore, right? And they made that red square in the bottom. Now, if you're actually using a standard tracker, this is the equivalent of taking out 20% of the capacity. No project can go ahead like that. So the customer called us and said, this is canceled. We said, 1 second, let's see if we can fix this. So we took our versatile trackers, we redesigned it around this hole, right? And we were able to build a project like looks like this. If you look at this, you assume somebody was either drunk or fell asleep in the middle of the design. Why do you have a hole in the middle of a power plant? And the answer is this is actually the versatility that allowed us to still continue forward and unlock the value of this land, even with all the challenges that we faced. Similarly, something that we know that is relevant in some parts of Romania from previous conversations is slopes, right? There's a lot of areas where we just assume we can't build on the location because of the steep slopes. I see Christina nodding very happily to this, right? Now, why are slopes such a challenge? Because if you take a random tracker that's a very long row, it cannot fit on the slope. The power transfer across the torque tube simply forces the land to fit the slope. What we're doing instead is we're taking the tracker, we're chopping it up to small pieces, and we're forcing the tracker to fit the slope. That allows us to reduce the cost of grading, right? And it allows us to do this in places that we previously could not build projects. What does this look like in real life? This is a project we did in North America. Someone mentioned Ormat before. This is actually to power one of the Ormat factories. You look at it from up top, and it looks fairly simple, nice square blocks. Why is this so difficult? Because when you look at it 3D, you realize, wait a second, this is on a mountain that nobody should be coming close to, right? Now, we did the analysis. We did what's called a slope analysis, and we found that about 90% of the land here was above 3%, which is typically the industry standard. So we looked at what you could do with a standard tracker. We looked at what you could do with our tracker, and we realized that this is the only way to unlock this area. This is what we presented to Ormat, who was the customer, right? And they realized that this is the only solution. Why? Because what we were showing them was a tracker that can actually be built on up to 30% slopes. That is nearly impossible with any, or it is impossible with any other structure. What we have here is a special joint that allows the trackers to adjust to the slopes. And that's what allows us to unlock these types of locations without the earthwork, the cut and fill, the civil work that would typically be required to build in this kind of a location. What does it look like? This is what it looks like when we drove piles, added the structure, right? And then this is what it looks like when you walk through this location. Typically, this is a project that could only be done with what we call a fixed tilt or a static structure, not with a moving tracker. Now, the reason that can happen is because oftentimes without the extra 20% energy generation from a tracker, you would be able to physically build the site. You would not be able to do it from a financial perspective. So by adding the tracker solution, we're unlocking it from a financial and from a technical perspective, right? And here you see a few examples of where we've done this around the world, many other European locations, Italy, Romania, Hungary. You even see on the bottom with this is an ABB factory. So very helpful for, again, behind the meter projects that factories are looking to co-locate. Some of the benefits of the tracker. So our tracker is actually very different than most other trackers in the industry. It's lighter, it's more versatile, it's optimized for what we call bifacial panels, where you have energy generation on both sides. We're doing a special layout to avoid any of the shading on the back of the panel, right? We're creating more energy, and we actually have the software that matches up with this approach in order to be able to optimize it. Now, as I mentioned, we are not a steel factory. We're actually a software and technology optimization factory. So besides making these trackers that are more effective and versatile, we actually have the SCADA systems, the plant control systems that are collecting the information, right? You see here the scheme going on. We're collecting meteorological data. It's coming back down. It's moving the tracker. And then we're collecting this information from all of the different components of the field. And that allows us to build a very sophisticated model. So we're not just looking at what in theory this plant should be doing, but specifically how much it should be generating in real time, so we can actually provide alerts and recommendations on what's happening in the solar field to continuously optimize it, right? And that's one of the things we're doing by breaking down the silos between all these data points. Now, with the challenging terrains that we mentioned before, it's not just about can we build on it, it's can we use the right algorithms that allow us to do what's called smart backtracking by making sure that the panels and the rows are not just pointing at the sun. Pointing at the sun is actually fairly easy. Knowing not to shade the row in front of you or behind you during all times of day, that's actually where there's a lot of sophistication. And what we're doing is we've created algorithms that can add about 1.5% of energy during the most valuable parts of the day. Again, we talked about those shoulders, the morning and the afternoon, by avoiding shading. The counterintuitive part, as you see all the way on the bottom, is sometimes we're telling certain rows to point away from the sun to not get shaded, but allow some rows to be at the right exact angle to the sun, which is how we're optimizing the whole field in a very counterintuitive way. These are the types of decisions that, as far as we know, no other tracker manufacturer is currently making. Now, you might think, okay, this is needed if you're building on the craziest terrains in the world. But what if I'm just building on a simple slope, right? Something that looks like this. This doesn't look too difficult. This looks fairly simple. And the answer is, even on something that looks like this, you see a little bit of a sloped hill, but it's fairly consistent. We took this type of a project and we broke it down into 20 plus different areas where each of the colored squares that you see on top was getting its own sophisticated control and algorithm to optimize the plant. That's how we're squeezing every single little juice of energy and money out of each square of this type of project. Now, if we're collecting the information, obviously we're also providing this back to our customers so they can monitor this in real time, and again, intervene if needed based on alerts, but also be able to incorporate this into their monitoring. Now, something that I recently learned, I was actually on a panel yesterday with a colleague or a gentleman from Romania, and I learned that Romania is now starting to consider what's called agrovoltaics, so building sophisticated power plants above crops. This is actually a project we did in Israel above vineyards, and as you can see, this is much more difficult. You have to take into account the crops. You have to balance the sunlight between the agricultural side and the energy generation side. That is both a hardware challenge and a software challenge. Why is it a software challenge? Because we need to be able to model this and make real decisions based on the information, right? So you see here a few examples of the different crops and some of the customers we've worked with above grapes, apples, lychees, tomatoes, avocados. We've done this in many different places. And what we're doing is we're connecting sensors from the crops that are measuring all sorts of photosynthesis activity, humidity, temperature into the solar controller. And that's how we're able to make these decisions. For example, it's the middle of the day, but we know based on the sensors that the plants need more sun. What we're able to do is we call anti-tracking. You see the panels shifting and you see the shade moving to the side and the sun actually coming to the crops, right? So this is an example of how we're able to balance that dual use. And again, when there's crops underneath, make that balance. It's also an example of the level of control and sophistication that we're able to add here. So to wrap it up, what is SolarGeek doing and why are we relevant for the Romanian market? We have the versatility to build plants and projects in places you previously could not build. We're doing it at lower costs than traditional trackers because we're reducing the amount of steel. They're very easy to maintain and install. And the level of control and sophistication that we have are actually generating more energy from that square meter than you would be able to do in any other scenario. Thank you very much for your time today.
Thank you, Moshe. Nice presentation. Unfortunately, the last company, Storage Drop, won't be able to present due to an accident, and I hope he is okay. So this wraps up our presentation session, and we are ready to move to the B2B session. Before that, I want to thank all the participants and the speakers. Thank you. And just wanted to tell you that we will be sending you the presentations of all the companies afterwards. Okay. So I will open the breakout rooms, and as I previously said, if anyone needs assistance with that, let me know, unmute yourself, and I will direct you to the breakout rooms. You will see a button.
Okay. Ok.
Să pe un anume? Care din ele?
Toate.
Puteți să-mi spuneți mie cu ce vreți să începeți.
Toate.
Cu toate.
Hai să începem cu lava.
Cu lava, imediat.
Păi ce era cu...
טוב, אז אני אגיד לך מה אני חושב על זה ואיפה זה מתנגש או לא מתנגש.
Domnule Stoicescu, vă mai gândiți?
Mi-au plăcut trackerele, ca să fiu,
Trackerele.
dar sunt pentru un client, adică intermediez doar aici.
Mhm.
Aș vrea doar prezentarea și eu să o trimit la Parapeci să vedem exact dacă au utilitate, că ei sunt singurii care instalează tracker de performanță înaltă în România.
Ok, stați să văd. Păi, dacă aveți ceva întrebări sau puteți să intrați direct în contact cu domnul Moșe, văd că el este încă singur în breakout room.
Ok, și cum intru? Intru direct...
Stați că vă direcționez eu. Assign to Solacic. Gata.
Ok, mulțumesc.
Ok. Domnule Anton? Bună ziua!
Da, bună ziua! Bună ziua!
Ați fi interesat să intrați într-unul dintre breakout rooms? Am văzut că ați întrebat și în chat box de prezentări, dar dacă...
Da, din păcate nu permite timpul acum, însă m-ar interesa contactele celor care au prezentat mai devreme, pentru că avem niște proiecte foarte interesante și chiar cred că s-ar dovedi niște tehnologii utile.
Vă referiți la SolarGeek, nu?
Nu doar,
Nu doar?
nu doar,
Ok. Ok.
nu doar. La toți cei care au prezentat până acum, din păcate, nu am putut să fiu atent pentru că am ceva de făcut.
Ok, în regulă atunci. O să trimit la toată lumea un follow-up email cu prezentările.
Super, mulțumesc mult!
Și eu mulțumesc. Și... Frate, Hello, Dor.
Hello, how are you?
Good, good. I just received Itai's message
Yeah.
that you have some technical issues. Yeah, unfortunately, there were some ladies that apparently left the session. So, and I think those were like suitable in your case, but I don't know why they just vanished all of a sudden from this session.
Mm, okay, so I did it wrong. I didn't have to leave.
Oh, you have to leave, sorry.
No, I didn't have
Oh,
to. I mean,
oh.
they joined the session and then they saw that nobody's here. They left.
I don't know. I
Okay,
don't know.
okay,
Maybe,
okay. That's
but
fine.
the thing is, they were really suitable for you as it was like an aluminum factory, the biggest one in Romania and actually in Europe. And they
Mm.
joined, not, it wasn't like only one person, there were two. Most probably
All good.
they were interested and we'll make sure that I will connect you afterwards.
No worries, no worries. Yeah, I mentioned to Itai before the webinar that we're not a storage. We're not doing storage. We're energy generation. Maybe the audience was a bit off, but that's okay. That's okay. I mean, improving our brand awareness and what we're doing is always good. Thank you for the opportunity. And yeah, if someone is interested, you have our contact details, and that's
Yes.
great. Thank you
Yeah.
very much.
Thank you. You can remain because there was someone that there is someone that wants to talk with all the companies, and right now they are in another breakout room. If you can wait a couple
Mm-hmm.
of more 5 minutes,
Sure.
that's
Sure,
not a
sure.
problem. Okay,
Yeah,
thank
that's
you.
okay. I'm here. No worries.
I will go there and check how they're
Cool.
doing.
Cool.
Understand. Okay. And this syngas can be burned, obviously, but the total carbon emissions is somewhere around 50% of the carbon emission from a typically incineration. It's
Yes.
okay. So it's a green technology, la la la, you know. Now, we need a power conversion, the energy converter. This is your job to convert the
Okay.
power. Give us, we need a converter, okay? Your device, your system, we think is very interesting for us.
Okay. So
Instead of
you give me the flue gases, the burn gases. I know I got a heat exchanger. Let's call it a shell and tube heat exchanger.
heat exchanger. Yes.
You can provide the heat exchanger, and I will connect to the liquid side. You are also developing the heat exchanger, or it's out of your scope?
We can design it. We can design it. No problem.
And
the heat exchanger according to your needs. According
yeah, of course. It's my process design. I'm designing the process.
Yes, we can.
I'm designing the heat. I'm giving the heat and mass balance, the energy balance that I need out of the heat exchanger. And what temperatures are we talking about of the flue gases?
Okay, the flue gases basically is somewhere around
build up to build up their own energy infrastructure in order to do all of this at once. So considering your product and the fact that it's higher up above the above the
agriculture crops.
Above the crop, and it allows the crop to grow and produce biological resources. That integrates a lot of my problems. Basically, I can produce digestion not only for energy production but also for methane blends. So it becomes attractive for all of the clients that want to get involved in this direct PPA to clean up the gas production in Brua, for example, which delivers Neptune deep gas to Germany, according to a contract we've recently signed. This would be a very good business development opportunity. However, the Constanța region, which is building PV consistently, is now blocked by grid permitting. So the grid is full. Modernization is not going to come because industrial consumption has not risen. So the only way for the projects that are now under feasibility, on their feasibility side to continue is for us to build a business development strategy by which they produce green ammonia and export it back to Israel and Japan, for example. That means a lot of renewables, some hydrogen production from those renewables, Haber-Bosch to produce, to break the hydrogen molecule into ammonia. So that's another 3 kilowatts above the cost of hydrogen production. Meaning we have Constanța with a huge harbor that can facilitate the loading, unloading, and the shipping of ammonia. And we'd have to think back with Christina here about a method to export ammonia and find off-takers in Israel, because I think green ammonia is going to be well regarded because you can convert it back to green hydrogen. And as Germany has this problem, you don't have.
You can change it by, you can resolve it by, different mass flows, etc. But let's say around 500 degrees, a bit more, it is becoming very complex and very expensive to harvest date. So
Understand. We will adjust everything, every input parameter according to your needs in order to make a good design. Okay?
Perfect.
Obviously, as I said earlier, we will have a lot of emails. We will conversate. So, expect from our colleague Mihai Doblețiu to stress you with a lot of emails. Okay.
Okay. Perfect. Thank you very much. Thank you.
We will look forward to cooperate with you. Really do. Thank you.
Thank you, Christina. Thank you very much. Also.
Just a second. Mă adresez acum către Wing. Vă direcționez către altă
baterie. Finergy.
Imediat.
Christina, sorry, I have to leave this room now because I have an unexpected meeting in 9 minutes. So we can continue offline. Thank you. Thank you very much.
Thank you so much. We will keep in touch via email for the presentation and the rest.
Let's take it offline. Bye bye.
Great. Bye. Ok, l-am mutat. Bun.
Very well, thank you. My name is Cristian Lungu. My colleague Mihai Doblețiu and my younger colleague Claudiu.
Nice to meet you.
Our company, Wing, is involved in research programs, and not only. We're specialized. We're from most of us from
in parallel.
That's actually who we actually source a lot of our steel from, ArcelorMittal, right? Like they're one of our steel suppliers for the structures.
And so this whole new business perspective in Europe, and I love it. I love the way they thought up this system. I'm sorry that Drill Baby Drill came into discussion. This is a whole other aspect, but the issue is the factory in Boden, for example. The factory in Boden solved the whole value chain of renewables. So what I'm trying to tell you, can we find a way, so what I'm trying to ask is, can we find a way to enrich your product and sell it as a method to produce, to solve multiple aspects in the value chain?
I mean, I think it can, but from my perspective, it's not we're a growing company, right? We're not a startup anymore, but we're a growing company. I don't know that I have the attention and effort to basically create an adjacent market. Meaning, I don't doubt that what you said is a good idea. I don't have the resources to build the project around that. Would I like to be involved in it? And do I think that it makes sense? Yes. Right. But I being Solar Geek, can't take on to try to build the ecosystem around it. In my mind, that's what a developer, an investor, and an IPP, right, will do, and then they'll look to bring together the right technology. I'm a technology solution provider, right? Now, I want my technology to be widely used and applied, but I'm not at the size yet where I can build the market, right? Like I have to find the right markets to fit in, right? So what I'm trying to do is figure out where can I add the most value. So I really agree, and I like your point about like the building over crops. That's why we did that, right? Like it was actually not part of our original plan, but we realized that it is a big enough market to chase by itself. So we added that capability. But we're not going to be the ones knocking on farmers' doors and saying you should build, right? Like we're going to find the parapets, the Hexsolars of the world, like the Photosols, right? Like those are the customers that we're going to find who are going to be hyper localized and be able to knock on the right doors.
Photosol is also working with us. Sun
I mean,
are specialized in chemistry and power energy, and we need, obviously everybody needs some good batteries for long-term reliable batteries and cost-effective batteries. Everybody needs that. So we think from what we saw from your presentation that your product is a very good for one. It's a very promising for us, and we look forward to collaborate with you, with your company, and we will inform you about our demands, our necessary, what we intend to do, and see if you can help us if you can provide equipment for our projects here in Romania.
Thank you very much. Apologies again for the choppy video. I don't know why it's like that.
No problem.
But next time, to our next meeting, I will improve that. And yeah, it sounds very interesting what you're doing and the project that you're facing. And yeah, let's start talking. I mean, let's start collaborating. Let's start transferring knowledge and data. So we will better understand what are your needs, and you will better understand what our solutions can provide you with. So yeah, let's do it. Let's do it. Sounds good.
In Romania, I do not know the fact that in Romania there are a lot of sun and wind projects, a lot of sun and wind farms, but there is a lack of storage because
80% of the production from corporate management, and 80% of the land is.
This is your job to provide the solution. Okay.
Absolutely.
Okay. And there are several very large, and I mean very large, hundreds of megawatt hour projects storage that we are involved in, and if your solution is as we think it is, I think we will stress you for your products. Okay.
Let's do it. Looking forward to it. Okay, thank you. So I'll ask.
Thank you very much.
Thank you. So I'll ask maybe Christina or you guys to provide me your email address or contact details. And
I think Miss Christina will provide you the email.
Cool.
Okay. And I'm really glad to meet you, and good luck in you are doing.
Thank you very much. Thank you. We'll be in touch.
That's our idea with the aluminum and the zinc air. It's a unique idea, and I know you have made a lot of tests in order to deep preparation of this metal in order to react with air oxygen. This is the great achievement. Congratulations.
Thank you. Yeah. I mean, it's not me. I'm just a business guy. My colleagues here, engineers, and we have the entire spectrum of engineers, like mechanical engineers, electrical engineers, chemists. We have everything here. And
Hello, Moshe. Hello again.
Hey.
There's a company that it's still in a breakout room with another company. They are kind of wrapping it up, and once they are done, I will direct them into this. If you can wait for a couple of 2 or 3 minutes or so.
Yeah,
Okay.
absolutely. I'm here, just doing some work.
Okay. Perfect.
Thank
Thank
you,
you.
Christina.
It allowed us to successfully develop this metal layer technology with the help of, with the support of other technologies and other that the 21st century provided us with. And we're the first ones in the world. And we believe that our competition is like 3 or maybe 5 years. We are 3 or 5 years ahead of our competition. And yeah, we're looking forward to collaborate with you guys.
Thank you. Thank you very much. Good luck. Thank you very much.
Thank you. Have a good day. Bye-bye.
Have a nice day, you too. Bye-bye. See you soon.
Vă direcționez și către SolarGeek, da?
Da, să rămână. Mulțumim.
Ok, imediat. Nu.
Christina, I'm leaving, right?
Just a second because SolarGeek. Okay, sorry. Yes, we are done.
Thank
The
you.
rest of the participants, as I said, vanished, but I will make sure that I will put you in contact with the people you spoke with.
Sounds good. Thank you very much, Christina. Have a good day.
Perfect. Thank you. Have a nice day. Bye-bye. Mi-a murit creierul. Cum mă duc în unassigned? O să mă mai duc? Dracu?
The storage. I spoke with your friends, your colleagues from for storage. So we have a solution for storage. Now it's about energy density, what we can grab from the sun. Just a small coincidence. We now have a project. It's about 80 megawatts of solar, 80 megawatts near to Bucharest, and it's a very flat terrain, literally flat. It's unbelievable flat. It's like a football field. It's literally flat.
You should know that even a football field is not actually flat. There's a 2 to 3% difference from the center to the side, so the water doesn't sit. So be careful with the metaphor, because even football fields are not supposed to be fat.
Yes, but the Romanian field in that part of the country, it's flat, believe me. You will see. You will receive the data. We know the data. That's why I'm speaking. Now, the first solution was obviously static. The static panels. But the owners want to inject energy into the grid on the peak. Yeah, okay. He must to pay ROI. Okay, return on investment. So the peak solution is the best for everybody. And in this case, we cannot speak about fix it. We need tracking. Okay. So this is your part. The storage, your colleagues said, okay, we can do it. But the tracking is your job. Now we can. I saw your presentation. I think it's a very, very nice one. Very interesting solution, and also not mechanically speaking, but logically speaking, the software is the key, in fact, in this entire system. So I'm very glad that we met you. My colleagues will send you via Christina. We'll send you our emails, and we will start dialogue. We will send you all the input data from our project, and you will analyze it, and you'll see, okay, we can help you. Let's see how, and we establish all the necessary documents you consider to start the collaboration.
Almost all of the material that you saw me present was information that we learned and put together during that process with other customers, right? Meaning all the grading analysis, the additional capacity, right? The software generation and control. That's exactly what we do in this phase is we look at it, we look at what you currently have, and then our job, as I think you pointed out, is to show you where we can make it better, right? Moving the energy to the sides, adding more capacity in the same land, reducing the installation cost, removing, in this case, it's flat, but basically, how do we give you higher ROI, right, to basically make the project more financial? We have an ROI calculator that is internal to us, but we use it when we do the designs to figure out sometimes, moving it in one way, even if it's not directly to the sun, but it allows us better access to the land, actually has a better calculation, right? So we'll show you a few of the options of what the current state looks like and what we believe it should like in the future and what the delta between the two options is from a financial value perspective. And then it's your choice, obviously, to make, we see it or not?
Oh, yes, of course. And you see that there are some issues. Romania is northern than Israel. 45 degree latitude it's in the middle of Romania, 45 latitude. And the differences between winter and summer in Romania are substantial, let's say. Most probably you will need also to face the panels somehow to the south a little bit, not only horizontal, but also tilted for the south, in order to increase somehow the energy density. Somehow, yes. And you'll analyze it. 35. We will send you exactly the GPS location to see exactly where it is. The location.
We have a very simple online intake form that basically lays out exactly like the minimum amount of information that we need in terms of all this information, KMZ or DWG, what other materials you plan on using. If you have an existing layout, that's what we take into account. Like we have a very standard intake form that I'll, once we get the emails from Christina, I can make that introduction and provide you with that form.
Yes, we will send you all the data. Thank you very much. You receive all the data from us. You'll analyze it, and after that, we will talk together with a conference with the customer, the beneficiary, and we are the designers from the power, and together we will set the coordinates of how to collaborate. Okay.
Fantastic.
Okay. Thank you very much. Thank you.
My pleasure. Thank you.
Thank
you very much. Very nice to meet you.
Very interested. We are interested in your product. And Mrs. Moraro, Christina will make the officials diligences for everybody in order to have a very quick and data exchange. Thank you very much.
Thanks a lot. Thank you. Thank you, everyone.
Thank you.
Bye-bye. Bye-bye. Have a nice day. Have a nice day.
I think that was all, and I can close the session. Just to let you know that this will close, and we will keep in touch via email. Thank you so much.
Christina, I'm also done?
Yes.
Okay.
We are done.
Thank you very much.
Thank you so much. Have a nice day, everyone. Bye-bye.
Bye-bye.
And maybe storage drop. another time.
Yes.
More
Yes.
interesting also.
Da, o să atașez și prezentarea lor în e-mailul de follow-up cu toate companiile care au participat.
A fost cum nu se poate mai bine.
A fost o plăcere.
Da, nu a fost,
a picat foarte bine.
Da,
A
a fost
picat
destul
foarte bine.
timp, nu i-am mai zorit pe oameni cu prezentările și așa s-a...
Dar chiar a prins foarte bine pentru că și pentru noi a picat, adică soluțiile lor și ce au prezentat ei, pentru noi pică foarte bine. M-a spus, pică ca o mănușă, tot ce au ei acolo. Și cred că putem colabora liniștit, pentru că chiar avem cu ce, avem pe ce să colaborăm. Proiecte sunt. În România acum avem.
Fingers crossed.
Exact.
Ok, mulțumesc mult de tot pentru
Mulțumim
participare și rămânem în contact.
Da, cu certitudine rămâne.
Și sper să...
Colegul meu, Mihai, o să vă streseze cu e-mail-urile, da, și pe colegii
nu mă stresează deloc, nu?
Da. Vă mulțumim foarte, foarte mult pentru amabilitate și pentru organizare.
Și eu mulțumesc pentru participare. O zi bună!
Doamne ajută, numai bine. La revedere!
La revedere!
Claudiu.